Hey guys, what's going on? It's Danny, and today we're going to be talking about hash sets. I've been gone for a while with lacrosse and AP exams, but I'm excited to start making videos again for you guys. So I actually also recently just finished my data structures and algorithms course, which I've mentioned in previous videos. And this is the course that has been teaching me a lot of this content, and it was very helpful. But I plan to continue my series on talking about data structures and the underlying implementation, as seen in my previous videos on short sorted collections. If you haven't seen that, you should go check it out. And today we're going to be talking about sets, specifically hash sets in Java, but sets is the overall idea. Now, before we talk about what a hash set is, how it's useful, why we need to know about it, I need to give a use case for it. I need to show you why it's truly useful. And that's what we're going to do with this problem right here. Find the duplicate in an array. So if you're a new computer science application student, or you're someone just learning data structures, try to solve this question on your own and let me know what solution you come up with, and in 1 second, I'll go to the next page. So here we can see the solution that you might have come up with if you're not too familiar with data structures, and this is called the brute force solution, and this has a time complexity of O of n squared, which is amazing. The way it works is it iterates through each value in the array and compares it to each other value in the array. It has a complexity of O of n squared because as it is checking each value in the array and comparing it to every other, it's checking all n elements and comparing each element to n other elements, creating an n squared complexity. Now, this is a great solution and what you might have come up with if you don't know what a set is. But if you do know what a set is, you'll likely know you'll likely have come up with what I have in the next slide. And before I show it, I want to explain what a set is. A set is basically a data structure that doesn't allow duplicates. And this is very useful because when we add elements into this set, we can easily check if they exist or not with O of 1 lookup, or very optimal lookups typically. Some downsides of a set are that it's not ordered, so you don't know what order they came in, and yeah, that's I guess that's really the only one. So now, to find a duplicate with a set, here's how it would work. If you just came out of CSA, I'll walk you through the declaration for a hash set. You have the name of the hash set, similar to an array list, of course, in the integer, then the variable name, and then the new hash set with just that. And then notice how inside of these carets, you don't actually have to write the data type. And that's because in newer Java versions, it's actually implicit. In Computer Science Club, I noticed a lot of people were including it in here, which can help, but you don't actually have to write it outside of computer science applications. Now, the way this code works is it iterates through each number in the array, and it checks if it exists in its set. If it does, it returns it. But if not, it's going to add that number to its set because it's just seen it. And the reason this is optimal complexity, it's O of n complexity, is because it only accesses each value in the array once. It only runs one operation as it scales. So it's going to access n elements, and then it performs an O of 1 operation, which is contains in the hash set. So basically, it's O of n, and it's faster, and it's more efficient. It's what we need. And the reason it's faster is because of the way a set actually works. Why is this better? A set uses hashing, which is something I plan on going into deep depth in another video, and that's going to be a slightly more advanced topic than this, and goes far more underlying. For LeetCode, and I guess not technical interviews, but primarily just for LeetCode, it's very useful to know just how the hash set works during preparation. But hashing is also very useful and something that's worth knowing. But the biggest use of hashing is that it provides O of 1 insertion, meaning when you add an element, it's instant, and also the contains operation is O of 1. This means that when you're checking if an element exists, it's O of 1. When you think of a typical array, if you're checking if an element exists, it's actually O of n, because you have to check each element in the array. And in a worst case scenario, you have to check every single element until it's the last one. Now, how does hashing work? I'm going to give you a brief overview real quick. Basically, you get this really big array, and then you hash it. You hash whatever key you're trying to input using modulo. So if it's an array of size 10, maybe you'll divide it by mod 10, and then you store it at that index. So here's a great diagram I found online that really emphasizes this. So here's an array of size 7, where they modularly divide by 7. For the first input, they want to input 7. To hash it, they modularly divide by 7, and then they get 0, and then they insert 7 at 0. And this works for all these different values, and here you can see the examples. Something that's useful about this that I'm going to be talking about in another video is called collision and probing. And basically, if you have two numbers that hash to the same key, you need a way to handle that. For example, 7 mod 7 is 0, but 14 mod 7 would also be 0. And we can't store 14 and 7 in the same index, and we don't want to replace it, so instead we have to do probing and all this other fancy stuff in order to handle these collisions, which I'll talk about in another video. Now, who cares? Why the heck do we want to use a hash set? We like using our array list. We like using our arrays, and that's because of the simplicity of the code. When you read these two arrays, it's not instant. You can't instantly tell what I'm doing in this. I mean, yeah, if you take a few seconds to look at it, you can, but when you look at this code, you can easily see you're just checking for duplicates with the hash set. And to kind of build off of that, whenever you are asked about duplicates or only like not repeating things, a hash set or a set is almost always the way to go because it doesn't contain duplicates and it's the easiest way to detect them. Another reason it's useful because of the complexity of operations. I'm not going to elaborate on that too much because I already spoke about that, but it's key to remember that the O of 1 lookup, the O of 1 contains operation, and the O of 1 insert or add operation is very useful. What makes a set a set? Now, those are some problems that we did in my computer science club, but today we're going to be talking about the problem intersection of two arrays. Now, if you can, I encourage you to try to find a solution to this problem on your own, but I'll be showing it in just a second. Now, here's the solution to this problem that I came up with, and it actually uses a hash set. Now, the brute force solution may do all this duplicate checking, and I don't even want to think about what that would look like because that'd honestly be kind of gross for this question, and that's why you need to use a hash set. The first thing we do is if we can zoom in. Oh, okay. So we declare a hash set, and we're going to store all of the numbers from the first array into this hash set. This means we know what elements exist in the first array, and we have a set of all of them with no duplicates. So we know like 1, 2, and 3 exist, and 4. But we don't need to know how many. We just need to know that they exist, and that allows us for this O of 1 lookup, and that's what we need right now. Now, we want to make another hash set called answer, and we're going to iterate through every integer in the second array and check if the first array contains it. The way we're checking if the first array contains it is through the set, because remember, for an array to check contains, that's O of n, which is poor, that's gross. We don't want O of n for contains in an array. Instead, we just are going to add to a set and instantly check if the set contains it. Now what this allows us to do is to iterate through each once separately, providing O of n, or O of 2n, which simplifies to O of n. We're doing O of n twice instead of 2 O of n inside of each other, which is O of n squared. That's where the complexity kind of expands and stretches out. But to elaborate on this further, you're going to check if my set contains the number, then you add it to this answer set. This allows us to guarantee that each value in this answer is unique as specified by the question. Finally, we just need to declare an integer array called return of the size of the hash set, iterate through the hash set, add it in, and return the integer array. And we get a beats 96.27%. Now, I'm sure there's micro adjustments and little solutions or changes you can make to this question in Java, but overall, this is the overarching concept that I'd recommend for you to apply if you saw a question like this. And so yeah, that's kind of the end of the video. This is a little bit of a shorter one, but I hope you got a better understanding of hash sets. But before I let you go, I want to give you one question to try it on your own to really solidify that you know what's going on here. And that's LeetCode number 3. Oh, where'd it go? It disappeared. Okay. Oh, I clicked that. Okay. So this is a longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. Now, I want you to try this on your own, but if not, if you don't think you can get the solution, I can give you a few hints. And then in another video, I'll go over the solution. So I guess one hint to this would be think about the techniques that you're using. We're using a set, right? Then another hint to have would be that think about how you want to iterate through this array in an O of n complexity because that's the best complexity. How can you go left to right and access all these values? Now, try out this solution on your own to this question. This is a medium, but I really think you can solve it if you have the knowledge I just gave you. So best of luck and stay tuned for more videos in the near future. Thank you.